Assalamualaikum warahmatullahi wabarakatuh. So I'm going to show you the solution for test 1 for question 2. Okay, let's take a look of that questions. Okay, for that the question for question 2 is that find a mesh current. Here you can see that mesh current, which is you need to find the I1 and I2, and also you need to find the node voltage, which is V1 and V2 in this circuit. So means that if you need to find the mesh current, what you have to do is you need to use the mesh analysis. Okay, so okay, here you have I1 and I2, so means that you have two mesh, which is mean that you need to have two equation. Okay, so let's take a look the mesh equation for I1 first. Okay, let's see for I1. Okay, the mesh equation. So we need to look at this loop. Okay, so from this loop, and then take a look at the arrow for the current directions. So the current directions is actually go this way lah. Okay, so what you have to do is just start it from here, the voltage source. You can go and see the sign here is the negative, right? So means that you need to start it with the negative lah. So means that -5 plus with, and then you can just add all the resistor here, which is in this loop, which is 2 plus with 4, where you have 6 I1, and then minus the outer loop, which is I2 lah, minus 4 I2, and then equal to 0. Okay, and then you can take a look at I2 mesh, which is if you started from here lah, see the sign here is negative, so negative 0.5 volts, and then plus with 5 plus with 4, which is 9, plus with 9 I2, and minus with the outer loop, which is minus 4 I1. All right, minus 4 I1, which is equal to 0. Okay, means that you have these two equation. All right, and then you have these dependent sources where you have 0.5 volts for V. So you need to find the constraint equation for V, right? Okay, let's see here. This V here is actually equal to V1 here. So means that you can write here lah, V is equal to IR2 here, IR2 times with IR2 times with R2 times with R2. So what is the value for this I here? Okay, this IR2 here. Okay, so if you look at this branch, okay, you can see that all the, let's say you just write like this lah. Okay, here is I2, here is I2, here is I1, and here is IR2 lah. So means that you can see that your IR2 here, IR2 is actually equal to I1 minus with I2. Okay, so you need to I1 and I2. all right, okay, so means that you can substitute this into here. So means that I1 minus with I2 times with R2, which is 4 ohm. So means that here you can get 4 I1 minus 4 I2 lah. Okay, so then if you put it here in this, substitute V here, so means that you can get -5 times with 4 I1 minus with 4 I2 plus with 9 I2 minus with 4 I1 equal to 0. So then you need to expand this. All right, so that when you expand, you get, you can get -6 I1 plus with 11 I2, okay, which is equal to 0. So next you can just just solve this between this equation 1 and let's say here is equation 2 lah. Okay, just solve both equation so that when you solve these two equation, let me just write it here lah. Okay, when you simplify that, 6i1 minus 4i2 equal to 5, and another one is actually here lah, negative 6i1 plus with 11i2 equal to 0. So for this one you can just add these two, okay, to kill this i1. All right, and then you can get here 4 plus with 11, so that you can get 7i2 equal to 5, right? So that you know that i2 is equal to 5 over 7, which is equal with 0.71 point over 3 ampere lah. Okay, so that's for i2 lah. Okay, say you already have your I2, which is equal to 0.7143 amperes. So now you can find your I1, which is you can substitute this value in equation 1, which is 6I1 minus with 4I2 equal to 5. So just 6I1 minus 4 times with 0.7143 equal to 5. So that you can find that your I1 is actually equal to 1.309 ampere. Okay, so means that you already have both value for current, which is I2 and I1. So now you can find the value for your V1 and V2. Okay, so your V1 is actually equal to V, which is if you look at the question before this, V is equal to I1 minus with I2 times with R2 times with 4, right? So means that I1 minus with I2 times with 4. So you will have 1.309 minus with 0.7143 times with 4. So here you can get the voltage V1 is actually equal to 2.3788 volts. All right, and for V2 you can find that V2 is actually equal to 0.5. All right, V2 minus V1 equal to 0.5 V. So means that V2 is actually equal 0.5 V plus with 1. Okay, plus with V1, so that here you can get V1 is actually equal, V2 is actually equal to 3.5682 volts. All right, so mean that here you need to substitute your value, the 0.5 times with this V and then plus with V1 here, and then you can get this answer lah. Okay, so now you've done lah. Okay, analyzing this circuit lah. Okay, thank you so much.